Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about a series of problems called jump game, and today we will be dealing with jump game 6, and the index you are seeing is 1696, and the problem is categorized as one of the medium type problems of the LeetCode. So we have been given a zero indexed integer array nums and an integer key. So this will be our array and this will be additional integer key, and we are initially standing at index equal to 0. Okay, that is, we are currently at index 0 first position, and in one move you can jump at most k steps forward. That is, if you are at a certain step, let's say this one. Okay, so this is the first step that you are at here, and suppose k is equal to 2. So you can either jump to this position or you can jump to this position, but you cannot jump to this position. Okay, this is invalid. So you can, it at any step you are at any position, you can jump at most k steps to the forward. At most k steps, you note that you can jump either to 1, 2, 3, or to the kth step from the current step forward without going outside the boundaries of the array. That is, you can jump from index I to any index in the range, this one both inclusive. You want to reach the last index of the array. Okay, and the last index is n minus 1, and our score is the sum of all the array values that we have visited during the course of the jumps. Return the maximum score that we can get. Okay, after reading this problem, you might be wondering that what could be the best solution of this problem. So rather than, you may be wondering that what could be the easiest solution for this problem. Okay, you must be thinking that for every step I can start my iteration and do the brute force technique. That is really worst thing to calculate for this problem. Okay, so what could be the optimal solution? First I will deal with the series of solutions. You can see I have got a first time of 460 ms per second. Here you can see I am just showing the solution first. I have just solved this problem, but the runtime is very bad using the multiset. And secondly, I have solved using the again the multiset technique, but still it is worst. Then I must optimize my solution. Then I found that yes, we can do something more interesting, and that is the concept of sliding window maximum. These are the two techniques using the multiset. This is really very easy to understand, but the concept of sliding window maximum for a particular constant size of sliding window is going to be like playing a vital role to solve this problem. And if you are unaware of that sliding window maximum, go and visit the description section of the video. You will find a tutorial to learn the sliding window for a particular array. If you have been given an array and if you want to find what is the sliding window for every size, for every sliding window of size equal to k, what is the maximum value present in that sliding window, then you can easily learn that concept. Okay, so I'm also visiting this one, sliding window LeetCode, I think. Yeah, or you can solve this problem also. Oh, okay, I think sliding window max, I've already solved that. It is one of the hard problems. You can solve this using segment tree, but I will recommend to solve it using Deque. Okay, so you can visit that, or you can learn the concept, visit the tutorial section present in the description section of the video. Now talking about this problem, let us first understand what could be the really explanation related to this, and then we will together build up the best solution for this problem. Okay, so let's move further. Suppose we have been given this array, and initially we are at this position, that is the position containing the value 10, and at any step we can move k equal to 3, at most k equal to 3 steps forward. Okay, that is, if you are at this 10, okay, you can move to either to this position, okay, or you can move to this position, or you can move to this position. I think 1, then 2, and then 3, at most 3 steps. Okay, there are 3 possibilities to go to next position. You can see whenever we encounter certain type of positions, try to think in a reverse manner. What is that reverse manner? Suppose we have been given only 2 elements, 10, okay, and 5, or let's say 6, one more element, and we need to find what is the maximum score that we can get. Try to think in a reverse manner. Suppose you are only at this position, that is the ith position of this array, and just try to ask some question with yourself. What is the maximum score that we can get if this is the end position that we want, that is ith position is the end of this array? Okay, then you will find an answer to yourself that, let's say it is an x. Okay, so if this is the maximum answer that you can get, maximum score that you can get at ith position of this array, then this answer can help us to build our further answers if there are more positions for this array. And how it is going to help us with the concept of dynamic programming, that is, for every ith position you can easily see, if you need to find out the maximum score for this ith position, and if you are aware about some if you are aware about what is the answers for the previous positions for this, that is the positions that are strictly less than I, and you know all the maximum answers, then you can easily find out the maximum score that you can get to reach the ith position. That is, for reaching this ith position, you are aware that we can reach this ith position from I minus 1, from I minus 2, up to last k positions, let that is I minus k positions, k minus 1. I think yes, this is. We can reach this ith position from I minus 1th position, I minus 2th position, up to I minus k minus 1th position. That is, from any of these positions, I can reach to ith position. Okay, and if you are aware about such thing, then you must be wondering that if we are aware about this I minus 1, I minus 2, and I minus k minus 1th position's maximum value, that is, what is the maximum score that we can achieve if we are at I minus 1 or I minus 2 or any of the positions that I mentioned over here. And if we know that I can reach the ith position, that is, what is the maximum score to achieve for the ith position, you can take the maximum of all these values plus my current value, current array value of this ith position. This is your answer. So here is the DP relation that you have got, dynamic programming relation. This is actually, many people categorize this problem as the hard one. I don't think so. This is like pretty much easiest solution. You must have to think upon that. Okay, so how you can build up that? So let me first write out the DP relation. Okay, so suppose you are at this ith state, DP of I. So DP of I would be maximum of, for all the values, maximum of DP of I minus 1, and it goes up to dp of I minus 1 minus k, I think. That is the last k steps on which we can reach to dp of I, plus my current value, that is cost of I, let's say, or nums of I, whatever you can write. Okay, so this is your dp relation. Okay, so what is the thing that you need to store, that is pre-calculate. You can just that is the main thing to calculate over here, is this relation. Can you calculate it efficiently? One thing is to do the brute force. I'm not going to talk about that shit. Okay, and this is going to be like really much important. Can we calculate this efficiently? Yes, we can calculate this efficiently. How we can do that? The first way that I've already shown you the solution using multiset. And what is that multiset solution? You can see, whenever we have found these values, I will store it in a multiset. And multiset stores stores the values in a certain order. And whenever we need to find the ith step, for the ith step, I need to find out these values for last kdp values from my current positions, that is the previous k values. That is, if you are at, let's say, 0, 1, 2, 3, 4, and if you are dealing with this step value, I can and suppose k is equal to 3, I can reach from 1 to 4, or I can reach from 2 to 4, and I can reach from 3 to 4. Yes, right? So if I can reach from these three values, I will store, this multiset will store the dp values of all these positions. Okay, and if multiset will store dp values of all these three positions, I will take the maximum from this multiset, and let's say maximum is value, and I will add it to cost of I, and this is your answer for the ith state. And suppose this multiset size, that is okay, there is one more tricky point over here. Like if multiset size, that is, increases by k, that is now the multiset stores these three values, right, for the fourth state, that is for index equal to 4. Now after calculating this state, I need to calculate for the fifth state, right? So if I need to calculate for the fifth state, I need to just maintain the multiset to store the values from 2 to 4, right? Since k is equal to 3. So I will have to delete the DP value of this 1th position. So this is going to be like really much important. Okay, so can I have to elaborate with some example? Let's say I'm going to take one example, right? So this is the example 10 minus 5 minus 2 403. Okay, so let's take another page 10 minus 5 minus 2 403 and k is equal to 3. Okay, so let's do some implementation type, not implementation time, just I'm going to explain what are the sequence of steps, right? So what I'm going to do is, suppose we have encountered this 10, so my current value is 10 and my multiset is empty. Okay, so this is multiset is empty and my current value is 10. So my previous value is nothing, like multiset is empty, so I will just store 10 as our answer. So dp of 0 would be 10. Okay, so this is done and I will put my multiset, that is I will store this 10 into my multiset. Okay, now comes the value minus 5. So minus 5 comes the value. So I will check it out. If I can reach I can reach this first position if I consider zero based indexing. This is the first position. So if I can reach this first position from any previous value or not, and I need to just check it out. I need to just figure it out. What is the maximum value present in this multiset? The maximum value present in this multiset is 10. So I can jump from this 10 to this 5. Okay, since k is equal to 3, still I am dealing with the correct value. So what is the my dp value for this fifth state would be like 10 maximum value present in this multiset plus minus 5. So it will come out to be 5. So if we want that this first position is the end of the array and I need to get the maximum score, my answer would be 5. So I will push 5 into again my multiset. Now if I am dealing with this minus 2, okay, now still you can see this my multiset size is not reached for k equal to 3. Okay, that is greater than k equal to 3. Okay, okay, so if I am talking about this minus 2, you can see I can reach this minus 2 from this 10 or from this minus 5. Since I need to figure it out the maximum score, I will pick up the maximum element from this multiset, which is 10. Then I will come from this 10 to this 2, and what is our answer? 10 plus minus 2, and it is coming out to be 8. So my answer for this step would be 8. I can jump from this 0th position to the second position directly. Since k equal to 3, I can jump at most 3 steps. Now comes the major thing. Also, I need to push up the value into the multiset. It is coming out to be 8. Okay, now comes the major thing. If I am going to deal with this third step, you can see my multiset, that is I need to come up from this okay, 1 2 3. Yes, it is still it is correct. For this third step, I can jump from 10 to 4. I can jump from 5 to 4, that is minus 5 to 4, or I can jump from minus 2 to 4. Any of the step is valid. So I need to pick out the maximum value from this TP, and maximum value from this TP is coming out to be 10. So I can jump from this 10 to this 4, that is 0th index to this third index. So what is my answer? My answer is coming out to be 14. Okay, that is 10 plus 4, 14. I need to push up this 14 value. Now comes the major thing. Since the size of the multiset becomes greater than 4, I need to pop out one element, because if I am dealing with 0, I can only jump from this minus 5 to this 0, or from this minus 2 to 0, or from this 4 to 0. I'm not going to jump from this 10 to 0, because the jumping from 10 to 0 is not going to cost me at most k steps, right? So I need to jump from minus 5 or from minus 2 or from 4, that is from first, second, third index respectively. So I need to pop out this 10, that is the dp value of this 10 that is present in this multiset. So this element will be popped out. So now becomes 5 at 14. So if I need to come to 0, I need to figure it out what is the maximum value present in this multiset. It is 14. So I will jump from this to this. Okay, so my value become 14. Similarly, you can do for all these steps and find out what is the maximum value present in this TP or for last index. So this is the multi-set solution. But this is not a good solution. Why this is not a good solution? Because let's talk about sliding window maximum technique to solve this problem. Let's move further. Okay, so I'm talking about sliding window maximum. And why I'm going to talk about sliding window maximum, you can easily find it out. Okay. Okay, so my array values are 10 minus 5. Okay, so I need to write down in a clear manner. My writing is very bad. 10 minus 5 minus 2. And what is the previous? So 10 minus 5 minus 2, 403. 403. Okay, if you focus one thing that okay, so let me denote. Suppose you are dealing with this step. Okay, so I'm not going to deal with this step. I'm going to deal with this step. If you are focusing one thing, that if you need to deal with this step, that is this position, the only thing that you need to encounter, only thing that you need to think upon that, and suppose k is equal to 3. So from what is the least index I from which you can jump from this least index I to your correct position? That is, since k is equal to 3, I can jump from least index I is coming out to be 3. That is, I can jump from this one to this one. I cannot jump from 10 to 0. It will cost me k equal to, it will cost me 4 steps, which is greater than k. Okay, least index I is this one, and this is my current position. So this thing, this will give you an idea that for every step of, that is for every position that you need to find your answer, you need to maintain the maximum dp value up to this window, and this is window of size k. And okay, so let me elaborate in much more another step, like suppose you are at position like a0, a1, a2, a3, a4, a5, a6. Okay, and suppose k is equal to 3. Okay, and if k is equal to 3, okay, so if okay, so k equal to 3, so 1 or 2 or 3. Okay, so I can write it as, suppose you are at this position a4, and what is the maximum, that is maximum least index I, that is least index I from which you can jump to a4. You can see you can jump from a1 to a4, right? So you need to maintain the maximum dp value up to this. As in the solution of multiset, you are going to, you are, we are finding this maximum value in this range. Okay, so this is the sliding window from a1 to a3, and it has the size equal to 3. And if you are, if you want the value, that is dp value at a5, you need to maintain a sliding window from a2 to a4, right? That is, this is the least index, and you can jump from this to this. And if you want the maximum score for position a6, you need to maintain the sliding window of the dp values of size equal to 3 from this to this. You can jump from this to this, or you can jump from this to this. Since k is equal to 3, you can jump from this to this. Okay, and what about if you are at this a2, you need to maintain a sliding window of this position. Okay, so this gives me the idea that for every position you need to maintain a sliding window of size exactly equal to k. Okay, and what about this position A2? We are not maintaining sliding window of size exactly equal to k. Here it is maintaining a sliding window of size k is equal to 2. Here comes something tricky, that is whenever I is going to be like less than or equal to k, I think. And if you consider 0, 1, 2, 3, you can see whenever I is going to be like less than or equal to k, you need to maintain a sliding window of whatever the element that is present just beneath, just behind it. Okay, and for the rest of the position, you need to maintain a sliding window of exactly size equal to k equal to 3, and we can easily find the maximum element of that dp value in that sliding window with the help of deque technique. What is the technique that I have mentioned? Deque technique. And this is going to be like really much important. If you're not aware of that sliding window technique, just go to the description section of the video. You will find a link to the video sliding window maximum of the problem that I've mentioned at the initially. And what is that sliding window LeetCode? You will find a detailed explanation of this problem where it is finding the sliding window maximum. You can easily elaborate that and find out the exact solution. Now I'm going to move further to show you the, this is actually that problem, sliding window maximum. You can see it is going to use a deque technique. The same technique I'm going to use in jump game 6 problem. Okay, so let's move further to find out the code. First I will show the sliding window code or this multiset code. Let's say I am going to use the multiset code first. And this is like, this gives us the idea that we need to maintain a sliding window of size exactly equal to k. You can see intn as nums dot size, and multiset of this not stored in like ascending order, it is going to show in descending order, since I have used a comparator greater int. For every position, you can see I have just find out the value. If set is empty, my previous dp value is 0. Otherwise I will pick up the maximum value, since I need to maintain the maximum score. And since multiset is sorted in with the help of greater int, my first element of this multiset, that is the top element of this multiset, will yield the maximum DP value for the previous k steps. Okay, and I will increment my nums of I plus equal to value. That is what is the maximum score that we can get for the current position. Now I will insert this my current value into my multiset, and whenever we found that multiset size becomes greater than k, as I have already explained in the explanation, I need to erase one position. And why I need to erase one position? Because I cannot jump from more than k steps, more than at most k steps. So I need to erase the entry of this I minus kth position, I minus kth dp value. Note that I'm talking about dp value, that is the maximum score for the I minus kth position. And finally I will return nums dot back. This is your answer. Okay, now talking about the sliding window technique, this is awesome, right? So I will maintain a sliding window of size exactly equal to k, or at most k. You can also say for every position, that depends upon whether my current position is less than or equal to k or greater than k. Okay, so this will be maintained using deque intq. And if you are still not aware about that, I will strictly recommend to visit the tutorial or that problem as I mentioned in the description section of the video. Check out that link. Okay, n is nums dot size, and for int I0 I less than n I plus plus, then I get the maximum value among the last k indices. It is going to be yielded by q dot front. And again, this is exact concept of sliding window. If you're not aware about that, check out that tutorial. Or nums of I is going to be incremented by that maximum value present in that sliding window, and I need to just do this operation. What is that operation? Since I need to push up an element into that my new d push up my element into the dq, I need to perform this operation, and this operation exactly comes from the sliding window technique. And if I is greater than or equal to k, I need to remove an element. Okay, and it is going to be like removed from the front element of the queue. Note that this process is efficient since queue takes exactly what insertion and deletion exactly equal to O of one operation. So because this is efficient, okay, rather than using the multiset. So this also gives you an AC code. So if you have any doubts, do let me know in the comment section of the video, and I will ask you to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.